Okay, we are going to continue on in chapter 5. We're looking at section 5.5, which is the design of crank rocker mechanisms. The last time we were together, we looked at two, if you would, versions of the slider crank mechanism, the inline slider and the offset slider. So we took care of those two. Now we just have this last one to look at. So in the application of a crank rocker mechanism, we have, instead of a slider with linear motion going back and forth, we actually have a link that is going to oscillate or rock back and forth. And if we look at our figure 5.6a, I'm going to go underneath our camera here, the top of page 116, this would be a good representation of a 4-bar mechanism that's a crank rocker. So the crank goes all the way around, okay? And then as we follow, link number 1 is going to be our frame, link number 2 is going to be our crank, connecting rod is number 3. And then as you can see here, our last link is going to be just a regular link, and it's going to oscillate back and forth. So you see that sweep or that throw angle that this is actually going to complete in one revolution of the crank. So this is going to be the type of mechanism that we're going to be looking at in this section. So if we go, let's just take a really quick, there's a couple of videos here, very short videos on YouTube. I'm gonna click on them, and we can just kind of see a quick operation of
residency. Look, Grammarly has again been a lifesaver.
Just love YouTube. There we go. Okay. So as we look here, I'm going to scooch this down here. You can see that the crank is going around. And as it does that, our output link is oscillating back and forth. And the full angle that this is going through, as we know, is called the throw angle. Okay, so very generic, basic operation of a crank rocker mechanism. On the next one here, we have a windshield wiper. So let's look at this one. Okay, here we can kind of see, and a windshield wiper in this case is a quick return type of a windshield wiper. But again, it's a 4-bar mechanism where that output link is going to just oscillate. Okay. And if we play it, oops, that's the wrong one. Sorry. That's not what I wanted. I want to go back to the other one. If we play it just one more time, because that's super short, here is actually where the mechanism is. You can see the crank is going around, and then it's connected here to that oscillating link that is going through the throw angle. And I know the last time we were together, this was one of the mechanisms that somebody had on their list and mentioned as a good 4-bar mechanism. And indeed it is. Indeed it is. Now, as we look here at the rocker or the crank rocker mechanism, we already mentioned throw angle, but the throw angle is going to be that angle between the extreme positions of the rocker link. So as we look at back underneath, you're going to notice that we have the standard joint callouts for our 4-bar mechanism. So A is going to start here at our crank center. B is going to be the input of the end point of our crank link, which is also the beginning of our connecting rod. It connects the connecting rod to the top of that output or that rocker link. Now you'll notice that it's called A, B, and then C. C then has 2 positions. We have C2, which is in its further point on our throw angle, and we have C1, which is going to be the closer point on that throw angle. Okay, so we'll be referencing these throughout. C1 and C2 were like the ends of the stroke and the closest point of the stroke when we were looking at that linear displacement on a slider. Now, a crank rocker can also be used as a quick return. And then you're going to notice here that this is one of the relationships that we're going to be seeing with a crank rocker. And it says here that the radial length between the 2 extreme positions is going to give us 2 times the crank length. Okay, so if we go back underneath here and we look at, and I'm going to actually scooch down here where they did the construction. if we look at where C2 and C1 are, the distance across, so yes, they are going to actually go along an arc. But if we take a straight line distance between the 2 points C1 and C2, we are going to get a length. And that length would be equal to 2 times our crank length. Okay, so there's a couple relationships that we want to add to our equation sheet that we have here. So I just want to use this little section. I might need a little bit more than that. So I'm going to kind of cut this off over here. Okay. And we want to add just a couple things about a crank rocker. Now, if you got to turn yours over, that's totally fine. I have a little bit of room here. And I think I can get it in. So this is going to be our crank rocker. Okay. And I'm going to say that this is figure 5.6 in our book that we can always go back to. So we have a throw angle in this case. Okay. And that is going to be the extreme positions of L. I'm going to say link number 4. I'm going to put a 4 with a circle around it. So link number 4. Zoom in a little bit further. Okay, so that's going to be our throw angle. We also are going to need to find the length of link number 4. In the case of link number 4, this is going to be an assigned value by the designer. Okay, so we are just going to arbitrarily say, I want my link 4 to be 4 inches long, to be 3 inches long. Obviously, if you're doing an actual design, you are going to have a better idea, but our book problems do not give us a length of link number 4, and we just have to then specify something, okay? Now we can also put here that, I'm gonna do a little thing here. I don't know how to do this. Maybe I didn't have as much room as I thought. L2 is gonna be equal to that distance between C1 and C2. So C1, C2, and we're gonna divide that by 2. And divide that by 2. And that was that relationship that we just saw on that previous slide. So once we get C1 and C2 in place, and we'll see that process, we'll just measure a straight distance between them. And then half of that is going to be the length of link number 2. We also can say that link number 2 is going to be the distance AC2 divided by 4, just like it was on the other ones. Okay, that's another way that we can get at it. And then we have L3 is going to be equal to 3 times L2. Okay, so that one was familiar to us in the last 2 setups or the 2 designs that we looked at. Okay. So these are going to be the items that we're going to keep in mind as we work through a problem. And that problem that we're going to be working through, I'm going to kind of scooch ahead here, is not going to, well, we already did 11, we already did 15. We're going to be working on 519 this time, okay? So let's go under our camera and we're going to take a look at page 120. And in the middle of the second column here, this is where we're going to be grabbing our problem statement. So it says here for problems 519 through 528, so the list that we have here, we're going to design a crank rocker mechanism with the time ratio Q as shown, okay, the throw angle as shown, and the time per cycle. So this is our T is equal to. Remember in the equations in the book, they call it delta T cycle, but this is the value for that, okay? It says we're going to use either graphical or analytical solution. We're going to kind of do a combination. We're going to do some calculations, and then we're going to go over to AutoCAD, and then we're going to graphically find some other elements. So these problems, just like the ones that we did the last time we were together, they are going to have some written work associated with them, but then you're going to be creating the diagram on AutoCAD, which will be part of what you hand in. And then it wants us to specify the lengths L1, L2, L3, L4, and the crank speed, okay? So let's go ahead and get started on this problem by doing some of the manual calculations here, if you would, Okay. So we're gonna look at, this is problem 519. And again, we're doing this problem because it's going to be similar to the homework problem that you have assigned, which is 520. Okay. They're giving us Q is equal to 1. The cycle time, so the change in T cycle is equal to 1.2 seconds. And then our throw angle is 78 degrees. So these are the things that are given to us. And then as it said, we want to find L1, L2, L3, L4, and then W2, which is going to be the rotational speed of our crank. Okay. Now, when we refer to as, just like we did last time, ones are the frame, okay, and this is going to be the distance between the two attachments to the frame. And we'll see that when we go through the example. But L2 is going to be the length of the crank, L3 is going to be the length of the connecting rod, and L4 is going to be the length of that rocker on the output. Okay. W2 is going to be the angular velocity or the angular speed of link number 2. Now we are going to start with calculating that angular velocity of link number 2. So we're going to say W2 is equal to, and if you need to go back to your equation sheet, we have the angular velocity of the crank is going to be 1 revolution divided by the total time for 1 revolution or the cycle time. So we're going to say 1 revolution divided by change in T cycle, which is going to be equal to 1 revolution on the top again. And then our change in T cycle is 1.2 seconds. Now, as we know, W is not reported in revolutions per second, so we need to convert it right away to revolutions per minute. So I'm going to do that right away here, 60 seconds, 1 minute. So now our seconds cancel, we have revolutions per minute. So our W2, if we take 60 divided by 1.2, we should get what? And I'll open up our chat box so I can see if anybody's filling in any answers here. Feel free to put them in for virtual if you want. What'd you get? 50 what? 50 RPMs. Did anybody else get that value? 50 RPMs. Anybody else get that value? Isaac is saying in the room here he did. Okay. Okay, so we'll put a box around that. So that's taking care of our W2. Okay, now the next thing that we're going to do is, as we stated earlier, we need to specify our length of the oscillating link, link number 4. So we're going to just come up with a value, okay? So I'm going to say our L4 is going to be equal to 4 inches, all right? 4 inches. And again, I'm assigning that assigned by designer, okay? The problem isn't giving it to us. We are just going out and we're saying, we're gonna have L4 4 inches long. Okay, so now this is where we start, going back to our CAD. So we're gonna go over to AutoCAD, opening mine up here. And we're going to start an inch increment start file. So if you want to pull that up, go ahead and do that. I'm going to pull up the one that I have started already. Okay, and I'm going to move this up here. Okay, now what I am going to do is I'm just going to copy just a couple portions of my finished one here. And what we're going to do is I'm going to kind of show you the whole process of how we're going to go through this. Okay. So I know that I have a 4-bar crank rocker mechanism. So that means that on my input, I'm going to be attached to the frame, and on my output, I'm going to be attached to the frame. All right. Now I'm going to start over here on my output, which is point D. Okay. That's the very end of my 4-bar mechanism. And what I'm going to do is I am going to draw a vertical line going straight up. Okay. This is my link number 4. Okay. This is my link number 4. And I want that link, as I stated earlier, I want it to be 4 inches long. Done. Okay. 4 inches long. So I'm just drawing that vertical. Now, this is where you would pick the number. You would also pick the orientation. And again, it's not giving us an orientation. It's not telling us a start angle to start our throw on. So this is where we are just going to make some assumptions, okay? I'm going to add a, oopsie, a joint up here, okay? And then this is going to be, I'm going to copy my letter right away. This is going to be point C. Okay, so it's going to be the top, oopsie, the top of, it's going to be the top of that link number 4. Okay, and it's going to be right there. And I'm going to add, you know, I've got one of those touch pads, and if you just graze the pad, so I'm going to put this right next to it. This is my link number 4. So I'm really starting, if you would, at the end of my mechanism. All right, because I'm starting with the output, just like we did when we did the stroke on a slider. We started with, okay, I wanted this to move how far? Okay, I want this throw angle to be how far? So I'm starting here. And I want that to be, that was 78 degrees, right? So if I take 78 and I divide by 2, how I'm going to distribute this, I'm going to put half on one side and half on the other. What do I get for an angle of half of 78? I'm going to ask virtually. Oh, I got 39. Lex is in there. 39. Excellent. So that means what I'm going to do a copy rotate on this link right here. So I'm going to hit my rotate command. I'm going to grab the joint at the top and just the link. I'm not going to worry about the other letters here. I'm going to hit enter. I just want to rotate those. I'm going to go down to the end point and make sure I get to the end or the center of that. And now you'll notice that I can rotate this as I move it. But before I do, I want to leave a copy behind. So you want to hit C, enter. And then now I'm going to put in negative 39, enter. And now it's 39 degrees clockwise from where I was at. I'm going to click on this and I'm going to change to a center line just so that it gives me that perspective of that side. Then I'm going to do the very same thing. I'm going to do the rotate command again. I'm going to grab those 2 elements. I'm going to go down to the endpoint here. And this time I want it to be 39 degrees. And this one, I'm going to change to hidden line. Oh, what did I not do? I didn't do the copy. Dang it. See, it's so easy to forget. And I remembered it the last time. Let's see. Undo. There we go. One more time. I'm going to do a rotate. I have to remember to do the copy. Base point, C for copy, 39, enter. And then I'm going to change this to the hidden line. There we go. Now that looks better. Okay, so those are my 2 extremes. And if I were to measure the angle between those 2, it better be 78, right? So if I do my angle and I go from this line to that line, sure enough, 78 degrees. Perfect. Okay. It's worth doing a little bit of a save here so we don't lose what we've got. All right. So those are my extremes. Now, as you recall, we're going to have 2 callouts on the left-hand side here. This is going to be C1. And over on the right, this is going to be C2. So we want to label those C1 and C2. Okay. So that's going to be the extent that those rotated. Now, does it have to be half on either side? No, you could put all 78 on one side if you wanted to. Remember, that's a call I made because our problem doesn't give it to us. And that's what you're also going to assume for your homework problem. Okay. Now, I want to draw the rest of my mechanism here. And as we saw earlier, one of the relationships that we have to calculate L2, okay, we go back underneath here. L2 is going to be half this distance, the straight line distance between C1 and C2, okay? So I'm going to go back to AutoCAD here, and I need to measure the distance between there, okay? So I'm going to do a linear dimension from the center of C1 to the center of C2, and I'm just going to get that value just directly above. I hate when dimensions cross, so I'm going to push this one up here a little bit. So the number I got, the linear distance, not the arc. This is passing over an arc. I just want the distance across, straight line distance between C1 and C2, okay? So what I'm going to do is I'm going to go back underneath here, and I am going to calculate my L2. My L2 is going to be C1, C2, that distance divided by 2. So that distance that I just measured was 5.035 inches divided by 2. So what is the value for my L2? Let's get some participation from people who don't normally participate. I appreciate those who do. So others should have their calculator out doing the calculations. I want to hear from you. Isaac is in the room here. He said 2.5175. Is that right? Okay. And that's going to be inches. Virtuals, you're going to be on for my next one. So I hope other people than Lex are paying attention and following along. I wonder sometimes. You can hide when you're virtual, can't you? I have my brave students are in the classroom, I think. Not everyone. I know that's not true. So this is my length
Hiding or lazy.
of L2. Okay, L2. So now I'm going to go over to AutoCAD, and we are going to draw where we're going to be putting our L2. Okay, or where we're going to be putting our link number 2. Now, the thing about where we're going to place this. Now, this is a Q of 1. That means that this is going to be when I go over to 2 and my throw angle goes over to 2 and it comes back to, step over to C2, it comes back to C1 and it goes back again. That oscillation is going to be the same amount of time, back and forth, back and forth. So that means that we are going to draw a line. Let's see what color, what I want. I'm going to leave it on the dimension layer. And I'm just going to draw a line, and I'm going to go from C1, okay, to C2. And then I'm going to extend it horizontally along that line like a distance, okay, just a random distance, okay? Now, if this was tipped and at an angle, you would extend it out past. Now, somewhere on this line is where I'm going to position that center of rotation for my crank, where I'm going to be putting point A, but how far? Okay. Well, we can go back and we can use that relationship that we know that if I know my value for L2 and I want to find the distance from A to C2, do you see how I can rearrange this to solve for AC2? And I can say AC2 is going to be equal to L2 times 4. Oopsie, off my paper. L2 times 4. So this is a rearrangement. So I'm using this right here. L2 is equal to, and I'm going to see that, right? So to calculate that distance where I'm going to go from C2, which is this point right here, and how far along is A going to be? It's going to be 4 times my L2 distance. So I'm going to go back underneath here. Since I just calculated my L2, I know that my AC2 is going to be equal to 4 times L2. So it's going to be 4 times 2.5175 inches. So AC2 is what value? Virtuals, you're on. Oh, Lex, Lex. I want somebody else. Let me see. That's okay. That's okay. I've got a lot of people online and I think sometimes we're depending on the couple of few people that participate and you're going to get more out of class. I know we're on our last class now, but you're going to get a lot more out of class if you're following along and participating. And that's why we do the practice problems. Okay. So let's go back now to AutoCAD and we're going to use this 10.07. Thank you, Chris. Thanks, Christian. Thanks, Josh. I appreciate it. Awesome. Isn't it more fun? All right, we're going to go back. Oopsie, wrong one. We're going to go back to AutoCAD now. And what we're going to do is we're going to draw a line that is going to be 10.07 from C2. So I'm going to draw a line. I'm just going to draw a random through that endpoint, just a vertical line. Okay. And I'm just going to do an offset command 10.07. And I'm going to click on it. I'm going to go to the left. This is the intersection then where I'm going to put my A. I see you wrote something, Christian. I'm going to get there in just a second. It would be fun if we had our cameras on with virtual backgrounds and then glare down at somebody's camera. It would be fun. You know, I toy with that idea. I am probably in the not so long future, not in this class anymore, probably require some cameras on only because I do wonder sometimes if people are participating and you really shouldn't get credit for being here if you're not. And I'm not saying it happens very often. You guys are really good, but the whole point is, you know, not just to hide behind your camera. All right. So, and I want you guys to feel more like we're in class and it's a community. It really is. Okay. So now here's the placement of my A, or the center of rotation for my crank. So I'm going to start putting my elements in place here. So I'm going to, I'll leave it on this one for right now. I'm going to do a circle that's going to have a radius equal to L2. So 2.5175. Okay. And then I am going to, around this one, I'm going to use my C, my original C. And I need to make this the length of my L3, but I didn't calculate that yet. So I need to go back underneath here. I'll come back to that. My L3, okay, we go back underneath. I know that L3 is going to be 3 times L2. So we're going to do 3 times L2 equals 3 times 2.5175 inches. L3. Oh, Josh is in there. 7.5519 inches. That sounds correct. Anybody else get that number? Sounds familiar to me. Yep, yep. 7.5525. But it depends probably what you had here or what you had here, if you rounded or not. So I'm going to go back to AutoCAD. And now what we're going to do is we're going to make this that distance. So 7.5519. Okay. And where it intersects with this particular circle, we're going to now draw our links in and label them. So I'm going to go from here to that intersection, turn them off my ortho, and I'm going to go to this endpoint right here. So this would be the placement of, okay, our links. So I need to label each one of these. So this means that this is going to be point B. Oopsie. B. And I'm going to add a pin joint here. Endpoint to there. Okay. And then I'm also going to add my link designations. So this is going to be 2 and 3. 2 and 3. There we go. So we have 1 is our frame, 2 is our crank, 3 is our connecting rod, and 4 is going to be our rocker or oscillating link. Okay, excellent. So this is just the generic placement. Now what we want to do is we want to position point B and it's furthest out so that it's sitting in line so that we accomplish our C2 distance. And then we also want to position it so it's on the other side and we can pull, you know, to where C1 is. So now what we're going to do is I'm going to change this to my center. I'm going to go line and I'm going to go from the center of rotation here to the intersection where I have my radius, and then I'm going to go all the way over to C2. Okay. And then I'm going to leave this radius in here, but I'm going to get rid of that one. So I don't have an extra one in there. Then I'm going to add my joint, and it's going to go right down here. Okay. So this is when I am in my all the way out position and I have my C2 accomplished. Okay. Then what we're going to do is we're going to show it in the opposite direction. I'm going to go to my hidden line and I'm going to do a line. And this one is going to be from the center of rotation to this intersection. And this is going to be the other position of B. Now, I'm not going to go over the top over here, but this would be like pulling it all the way back so that then it's pulling, if you would, C1 in its closest position. Okay. So that means that I'm going to have a B1 on the left-hand side here and a B2 on the right-hand side. So I'm going to add 1 and 2. Okay. So everybody kind of see these values, okay? These labels, if you would. Now we want to add these dimensions that we've calculated as well. So I'm gonna go back to my dimensions. And the ones that I want to add are going to be the ones that we calculated. So we want to show the length of link number 4. So because it's kind of at an angle here, I'm going to do an aligned dimension and actually, oops, an aligned dimension. And I'm just going to go from C2 down to D. I'm picking C2 just because it's out of the way. If I put it in the middle here, it's probably going to cross over some things. I can also get rid of this radius now, and I can get rid of that. Oopsie, not that line. Yeah, over here, there we go. So I've got the length of link number 4, okay? Now I need the length of link number 2. Now link 2 is here, so we could do an aligned dimension there, but I think I might do it from here to here, just because I can see it there. Oh, why is that 2.6? I thought I did 2.5. Oh, did that? Try it on this side. I go from, maybe I grabbed the wrong point. There we go. Okay, I might have grabbed the wrong point on the other side, meaning maybe it didn't hit the center of the circle. Okay, so that's going to be the length of link number 2. Okay, and then I want to add in the length of link number 3, which probably will be best along there. So I'm going to have to do an aligned dimension from B to C. I hate it when I go over the top of different things. I'm going to move this one over here. There we go. I guess that's not too bad. Remember, this isn't a drawing that we're going to release to production. So if we have a little bit of crossing, that's okay. But try to get your numbers so that we can see the numbers. Okay. All right. So I'm just going to kind of peek. I have L4 dimensioned, I have L2 dimensioned, and I have L3 dimensioned. So the only other thing you would want to add to these are which ones are which. So I'm going to just grab my B over here. This is going to be my L3 is equal to, right? This is going to be, grab that L3 equal to, this is going to be my L4. And then this is going to be my L2. change this. And again, make sure that you add these labels so I can see that you know what all of your values are, both what you calculated and where they are on each one of the diagrams that you do. Okay. All right. Okay. So far, any questions? All right. Now we do have, if we go back over here, we do have one more variable to solve for. So far we've gotten L4, okay, which we specified right here. We calculated L2, and we also calculated L3, okay? The one that we haven't done here yet is L1. And I'm going to show you how to put L1 in, okay? L1 is going to be an aligned dimension, not a vertical or a horizontal, from the center of rotation at A to the center of rotation at D. It's this dimension right here, and we get this one from CAD, okay? I have two L4s. Oh, I do, you're right. Thank you for letting me know. There, oh, that's an L2, sorry. Not an L3, L2. Thank you. Yeah, L2, L3, L4. So this dimension, 8.167, we are now going to add that to your manual work. L1 is 8 point, now I forgot what it was, 167 inches. And this one was gotten from CAD, so. Okay. So for this problem then, we have all of the variables calculated, okay? So you have to show the manual work here with all the identifiers, and then you're going to attach your screenshot showing all the elements that we see here. So anything that you calculated. So this is, actually I got to add my L1 label, right? L1 is down here. So this is going to be L1. So I've got L1, L2, L3, and L4. Okay. And then I kept in that length from C1 to C2. And then your identifiers for your links and your joints, making sure that you show the two positions of B and the two positions of C, as well as don't forget your throw angle as well. So kind of all the important stuff. Okay. I'm going to do a quick save here. So screenshot is worth 10 points for these last three problems. And then our manual work is worth 10 points as well. So you'll notice on the assignment, the last three problems are worth 20 points each. Okay. All right. Any questions on this problem 519? That's it. Okay. Then let's do a brief overview of the homework. I am going to go back to Module 8, and we're going to look at, let's first look at our practice problems. So the practice problems that we did were practice problem example 5.1. This was just calculations using the variables that we learned on our equation sheet, okay? But then problems 11, 15, and 19 were the two-part design and then also create the AutoCAD diagram of each one of these. So the manual work for those is what we did underneath the screen, and then the screenshots of the AutoCAD for each with the labels that we showed, okay? So that's the practice problems. Then when we go over to our assignment, number 8, we have the first two problems. These two are going to be the first two that are going to be calculations only, no diagrams. So notice those are only worth 10 points each. I did add the answers here for you, okay? So you should get these. Remember 5.4, look to use two equations, two unknowns for that one, all right? Then the last three problems are going to be worth 20 points, 10 points for the manual work, and 10 points for the AutoCAD diagram with all the labels, you know, that correspond to the calculations that you did, okay? So, so the 3 problems that you're going to be doing are going to be 12, 16, and 20. We did problem 11. That's going to be the process you follow for 12. We did 515 as an example problem. So, you'll use that as your guide for 16. And then we just did problem 19. So problem 20 is very similar. You can use that as a guide. Now remember, you have the freedom to pick the length of link number 4. For problem number 20, do not pick 4, okay? Don't do 4, pick another number. Additionally, you also have the freedom to change the angle here in terms of how you distribute it. Okay, I just made a vertical line and went half on either side. You can do that if you want to, but you could also tip this if you wanted to. You could put it all on one side or have an unequal distribution on either side. You are the designer. You get to pick that, okay? So, so those are 2 assumptions. Those are not in the problem, and then you go from there, okay? So I don't want anybody saying to me, well, how long do I know? You know, where do I start here? I'm going to say, go watch the video, okay? Because I've explained that a couple different times. Those are going to be things that you just have to pick. All right. So with that, are there any questions on practice problems or the assignment? All right. It doesn't look like it. So that means that that is the end of what I wanted to present for module number 8 here. So I am going to stop our recording. Okay.